Hey guys, welcome back to another edition of Geometry. I'm Mr. A here, along to guide you on your journey through geometry. Alright, today we're going to talk about three-dimensional figures. Our objectives for today, we're going to identify and name three-dimensional figures, and then we're going to find the surface area and volume of some figures. Alright, so where we're going to start today is we're going to talk about a polyhedron. Alright, a polyhedron is a solid with all flat surfaces that enclose a single region of space. Okay, so what that just means is that in your shape, whatever it is, let's see, I don't know if I've got room to write here or not, but somewhere I might. So in your, it's a three-dimensional solid. So let's say, for example, you might have something like this. Okay, so that would be considered a polyhedron because notice this is a flat side, that's a flat side, that's a flat side. All of its sides are flat surfaces, and it basically closes in this region of space. So we're going to talk about several different types, names that we have for polyhedrons, but this is an example. They can look other ways as well, but that will be one example. In a polyhedron, then, you're going to have what's called a face. Okay, so each flat surface of the polyhedron is considered a face, and that's a polygon. So in this case that I've drawn here, a very simple one, like this out here, this side, this is a face. So like this, that's a face out here. Over to this side, that's a face. The top one's a face, and of course each side there is a face. The edges are the line segments where the faces intersect. So where we have two faces come together, it makes an edge. And so like right here, this would be an edge right here, or right here, or right here. Any place where it's a straight line and two faces come together. It has to be a straight line though. We'll talk about if stuff is curved in a second. And vertex is the point where three or more edges intersect. So for example, in what I've drawn up here, you have this front face and the side and the top all come together right here. That is a vertex. So the points of each one, that's a vertex. Here is a vertex over here. So each place that you have a point on there is a vertex. Okay, so a couple things here. We're going to talk a couple of types of polyhedrons that we're going to talk about here. A prism and a pyramid, and then we're going to talk about some other shapes that are not considered polyhedrons because they have curved surfaces, and that's what I was talking about before. It's not a polyhedron if they have curved surfaces. But here's the one thing that's kind of interesting when we start naming these is polyhedrons are named by the shape of their base. Okay, and so when we start talking about these, I'll go a little bit more in depth, but the shape of their base kind of determines what you call it. So first of all, a prism, it is a polyhedron. Okay, so a prism is a polyhedron. It has two parallel congruent faces. Okay, so that's going to be, if you can see here on the drawing, underneath this surface down here and on top that surface, those are parallel. So remember we've talked about parallel lines before. Well, these are basically parallel planes. So they're flat surfaces. They're parallel to each other. They're the same size and they're the same shape exactly. And then they're connected by these parallelograms. In this case, rectangles of some sort. These are called bases. So the top and the bottom are called bases. Okay, so the bases are the two sides that are exactly the same in a prism. And so remember what I just said a second ago, they're named by the shape of their base. So in this situation, if we look at this, we say there's 1, 2, 3, 4, 5 sides to that base. So that would be considered a pentagon. And so what we would call this particular prism was we'd call it a pentagonal prism. Pentagon, pentagonal. Okay, if this base had 6 sides, we might call it hexagonal, or if it had 8 sides, we might call it octagonal, an octagonal prism. So depending on what the base is, that's how we would determine that if it's a prism. Okay. Secondly is a pyramid. Pyramid, as you can see, looks slightly different. It is a polyhedron as well. It has a base that's a polygon. In this case, it looks like it's a square or perhaps a rectangle. And then it has 3 or more triangular faces that meet at a common vertex. So here, this one, it looks like it's got 1, 2, and then around the back 3, and around the side 4. 4 triangles that come together to this one spot up here. That would be a vertex, okay? So the base is this down here, and then the vertex is up here. On this one, again, each, like this would be an edge. That's an edge we talked about. Each one of those triangles would be a face. The vertex is the point of it here. Also, pyramids are named by the shape of their base. So in this case, since this has 4 sides, we might call it a square pyramid, or perhaps a rectangular pyramid is what we might call that. Okay? All right. Next, we're going to talk about some solids that are not polyhedrons. Okay, first of all is a cylinder, as you can see down here. It has congruent parallel circular bases. So that means the bases, it's kind of similar to a prism. It has 2 bases that are parallel. It's just that instead of being like up here a pentagon, they're circles. Okay, the 2 bases are top and bottom are circles. And they're instead of being connected by all these different flat surfaces that are rectangles, they're connected by a curved surface around the edge of the circle. However, keep in mind, according to our definition of edges before, a cylinder does not have any edges. The edges are only where flat surfaces come together. So it does have 2 bases, but it does not have an edge, or it wouldn't have a vertex either. Any vertex or vertices. One thing here that, let me mention this though, is since we're talking about the base as a circle, like if we were going to name this base, I'm going to write in here, let's call this A, and down here we'll put B. That's the center point there. And so like if I was going to name the bases on these two, I would call it circle A and circle B. Here's a little symbol, if it lets me write long enough. That the circle with a dot in it, that's the symbol for circle. So we could say circle A and circle B are the bases. Okay, so these are the bases. My handwriting looks pretty bad today. All right, but anyways, that's the symbol for a circle. If you wanted to, you could write out the word circle as well. All right, moving on. A cone. A cone it has a circular base. So again, it's got a circle for a base. Let's say this time I call this C. Connected by a curved surface to a single vertex. So a cone looks a lot like a pyramid, except for, again, the base is a circle, and it's a curved surface that goes up to a common vertex up there instead of flat surfaces. And so once again, like on this one, if I was going to name the base of this cone, I would call it circle C. Okay. Again, it does have a vertex, but no edges on a cone. And I guess technically the only face would be the base on that. And then finally, the sphere. It's a set of points in space that are the same distance from a given point. So the given point is right here in the middle. And so from the middle, if you go any direction in any way, it's the edge of this circle here, or sphere, is the same distance away from that center point. Okay, and in this case, it doesn't have any faces, doesn't have any edges, no vertices. It has nothing. A sphere has nothing. Okay, so those are a couple of the different shapes. All right. Let's take a look at an example then. We need to determine whether it's a polyhedron. First of all, then identify it and name bases, one face, one edge, and one vertex. I said just do one of these because there's a lot of faces and edges here. I didn't want to get naming those for all eternity here. So first of all, is it a polyhedron? Remember, a polyhedron is made up of only flat spaces, okay, or flat surfaces. So if you look at this, you've got, if you look at the different sides, these are all just flat surfaces. So yes, first of all, yes, this is a polyhedron. Then identify it. Okay, well, remember the different types that we looked at. Well, this looks like it's got a flat surface here, and on this side it looks like it's that same exact flat surface. They're parallel to each other. So this is a prism, because remember a pyramid comes together at a point. So it's a prism, and if you count the sides here, 1, 2, 3, 4, 5, 6. 6 would be hexagon, and so this would be a hexagonal prism. So this is a hexagonal prism. Alright, so name the bases. If you remember from a previous lesson, when we name a polygon, like this is a polygon, remember a hexagon here, we just name the vertices and we go in order around, you know, it doesn't matter really where we start, but we have to go in order. So if I called, I'm going to start with K here. So the bases, there are two bases. So one base is K, L, M, N, O, P. Okay, so I go K, L, M, N, O, P in order. Again, if I wanted to, I could go P, K, L, M, N, O, but it has to go in order. You can't just jump around. K, O, L, M, P. Can't do that. Okay, so one of those bases is that, and then the other base is over here. And so I'll start with E, since that comes first alphabetically. So E, oh no. There we go. So E, F, G, H, I, J. So that would be the other base there. Okay, one face, and again there are many faces here. There's the two bases that we've already named, but then there's all these other faces. Let's just name one of those. I'm going to name this one on top here, and so I'm going to name this is one of the faces. I'm going to go with K-E-F-L. K-E-F-L. And if I wanted to, I could have put the little square or rectangle symbol in front there to indicate that it's a quadrilateral. You know, there's other ones you could do there as well. An edge. All right, so an edge. How about this one right here? That edge right there would be line segment LF. So we could just say LF, line segment LF. You know, there's tons of other ones there. There's MG, there's FG, GH, and so forth. That's why I didn't want to get into naming them all. All right, and then one vertex. So also one vertex. And so in this case, let's go totally different, and let's go over here to N. Okay, so point N right here, that would be a vertex. So point N. Also, there's point K and L and M, and every one of those is a vertex. Okay, so I didn't want to get into naming all of those. That's why I just wanted to give you an idea. Okay, same thing here, but this time we've got a different solid. And so it says, determine is it a polyhedron. Well, remember, a polyhedron has to have only flat sides, and if you look at this, this is a circle. And so this is a curved surface, and so this, no, is not a polyhedron. Identify it, though. If you look at it, you go, okay, circular base, and it goes up to a point. Well, that's what we call a cone. So you remember, like if you're getting an ice cream cone, you know, flip that over. It's like a waffle cone there, which, by the way, are my favorite. Waffle cones are my favorite. All right, so name the base. Well, it's only got one base. So the base is just this circle, right? Since it's called T here, the base is just circle T. Oops, I got two dots in there. There we go. One face. Well, really, the only face on this one is going to be the base again. So I guess if you wanted to, you could say that, but it's really the only face is the base. One edge. Well, you know what? Remember, the edges can only be when flat surfaces come together. So there are no edges. And the vertex, so we do have a vertex. We have one vertex, and that vertex is point W. So point W right up here. Okay, good. One more here, and this one, all we're going to do is just determine, is it a polyhedron, and identify the solid. So does this have all flat surfaces? The answer is yes, it does. So it's a polyhedron. What is that solid? Well, if you look at it, the two ends here are exactly the same shape. They're a triangle. And so this would be called a triangular prism. Okay, good. All right, moving on. Surface area and volume. Okay, surface area is just a two-dimensional measurement of the surface of a solid figure. And the volume is the measure of the amount of space enclosed by that solid figure. So kind of one way to think about it is think about, you know, back in the old days, you used to buy oil for your car in cans, and so they looked like, you know, they looked like a cylinder. You know, we talked about cylinders, so it was circular on the top and the bottom. Boy, that's really bad there. But, and so anyway, it was something like this. So sorry for my bad drawing. Anyway, oil came inside this, and then you would pour that into your car when you wanted to add oil to your car. Well, the surface area is like the can that it comes in. So that's the outside, you know, these two outside circles and the edges all the way around. That's the surface area. The volume is the oil that goes inside of the can. Okay, so that's what's inside of the can is the volume, and the can itself is the surface area. The units of measurement, by the way, on these, the surface area, since it's area, that's like two dimensions there, that will always be in units squared, or square units. And volume has three dimensions, length, width, and depth. And so that would always be in units, whatever the units are, cubed. Okay, so keep that in mind as we go through that. All right. So here are some formulas. I'll just briefly highlight a couple of things here about these, and then we'll do a couple of examples, and that'll be it. On these, the surface area, you can see you got for prism, rectangular, pyramid, cylinder, cone, and sphere. You can see the formulas here. Keep in mind, some of these, you're going to have to do some calculating before you can put it in. So for example, on this first one here, for a prism, it says big P, it's a big P, which is the perimeter of the base. So what we have to do is, I'll look at it like this. I'll look at this as being the base down here. So that surface down there is the base. So we're not going to have just a single number from the figure that we can put into that formula. We have to calculate it. So let's say, for example, this was 6 inches, and let's say on the side here was 4 inches. And so if that were the case, to figure out the perimeter of the base, we would do what? Well, if this is a rectangle, we know that this is also 6 over here, and on this side over here it's 4. Okay, so what we would do is we would add that up, 4 plus 6 plus 4 plus 6. So that would be a total of 20. Okay, so we have, in that case, we would have our total perimeter would be 20. So that's 20 is what we'd put in for P. H would be the number that goes up and down, and so that would be given to us. And then it says plus 2 times the base, big B base, which is the area of the base. So we'd have to go back and do a calculation here again. And in this case, to find the area of this base, we're finding the area of that rectangle. We'd have to do what? Length times width. So 6 times 4 would be 24. So for big B, we would then put in 24 here. So see, a couple things there. The big P and the big B, we have to calculate something first on the base before we can plug it in. And then you can see on volume, again, we got a big B, so that would be the same thing, the area of the base. Under the pyramid, one thing here that's a little different, you still got a big B, so that's the same as what we did before. You still got height. Now the height, they don't write it in this drawing, but the height is from the vertex up here of the pyramid straight down. I don't know if I can draw this very well, but straight down to the middle of the base there. So that's where that's the height is going to be, that number straight down to the base. So the L is from the vertex down the side of the pyramid. Okay, so that the L is down the side and the height is straight down into the middle of it. Okay, so that's the height and the L. And of course we already talked about P and B. That's the same thing as it was in the prism. Cylinder, pretty straightforward. You're just given the radius in your formulas here is just the radius of the circle that's the base. So, and then the height would be how far it is from one base to the other. That would be the height. So you just plug those in. The cone height would be similar to the pyramid, you know, from the vertex straight to the middle of the circle. The radius, again, would be the radius of the base or the circle. And once again, L would be down the side of the cone, from the vertex down the side of the cone. Okay, and you'd plug those in. And then, of course, finally, in the sphere, all you've got is the radius, which would be from the very center of your sphere out to the edge. And then you'd plug that in. Okay, so a few things about that. Let's just do a couple of examples now. All right, find the surface area and volume of the cone. Okay, so first of all, if I can find my pen here, so your surface area, I think on the thing that was on there it said T, but I like to use S for surface area. So same thing. So the surface area there would be pi r L plus pi r squared. I don't have that memorized. I'm looking at something here. Okay, so let's plug in what we can. Well, we know we got pi. Well, what's r? If you look over to our drawing here, remember the radius is from the center out to the edge of the base. That would be 3, so we can plug 3 in here for the radius. L, remember, was from the vertex down the side of the cone, so that would be 5 plus pi times radius squared, and again radius is 3 squared. So now all we have to do is calculate all that out. 3 times 5 is 15, so I'm just going to call this 15 pi right now. Remember, please excuse my dear Aunt Sally, you have to do 3 squared. You have to do exponents before you do multiplying, so don't go 3 times pi and then square it. You have to do 3 squared, which is 9, so I'm going to call that 9 pi. So that means we have a total of, when we add these together, it's really just 24 pi. Okay, then I'll take the calculator and I'll just type in 24 times pi. Use the pi button, not 3.14. And so what I end up with here is 75, and I'm going to round it to 1 decimal place, so 0.4. It was 0.39, and so I rounded that up to 0.4 because I cut it off there. Units of measurement here, we got centimeters, and since this is surface area, there's 2 dimensions, so this would be centimeters squared. Okay? And then the volume of a cone would be 1/3 pi r squared h. Okay, so we'll plug that stuff in. So 1/3 pi, again our radius is what? 3. And the height, now the height is, this is L over here, remember 5 is L, so the height is this one, 4. Okay, so remember you have to do exponents first, so 3 squared is 9. So 1/3 pi, and then 9 times 4. And then 9 times 4 is 36. I'll just do each step here. And what you can do, a little trick here, if you don't know what 1/3 of 36 is, you could just take 36 and divide by 3 would work. And so this would be 12 pi. And then once again, we can just plug that into our calculator there. So 12 times pi, which is, it's 37.699. And so when I round that off, it's going to be 37.7. It'll round up to. And since this is volume, this will be, volume will be in centimeters cubed, or cubic centimeters. Okay? And then one more here. Let's look at this triangular prism. Now this prism doesn't look like the prism in the what I showed you with the different formulas, but we're still going to use the formula for prisms. Okay? So the prism formula for surface area is big P times H plus 2 times big B. Okay, so if you remember, big P was the perimeter of the base. Now this is sitting sideways. Okay, so the base is not on the bottom. The base are the two triangles. Remember, the bases are the two parts that are exactly the same size and same shape. So the base is this front edge here. Okay, that's one of the bases there. And so, oh, you know what we're going to have to do here? We are going to have to, I'll tell you what, I'm just gonna put it in here. This is going to be 10 feet. So 10 feet is this area here, just to save us some time. If you didn't have that written in as 10 feet, you'd have to do the Pythagorean theorem, a squared plus b squared equals c squared, and you have to work that out to get 10. But in this case, it's 10. All right, so so the perimeter here, you just add up these three sides, 10 plus 8 plus 6. Okay, so I'm going to just do this off to the side here. So 10 plus 8 plus 6, which together would be what? 24, right? So the big P is 24. The height is this 12 right here, plus 2 times B. And remember, the B is, that's again, what's the area of this triangle? So remember, 1/2 little b base times height. In this case, what I'm going to do there is I'm going to say make the base 8, and the height would be 6. And so we can work that out. And so this would be 6 times 8 is 48, times 1/2 would be 24. And so that's what we're going to put in for the area of the base. Well, that's interesting. And then when we work this out, we've got 24 times 12, 288, and plus 48. And so altogether, 336, and that would be in feet squared. Okay, because that's the surface area, 2 dimensions. Very last thing, volume. And the volume would be big B base times height. Well, fortunately, we've already figured out the big B over here. But from before, we got 24. And the height, again, is 12. And so all we have to do there is 24 times 12. And that would be 288. Since it's volume, that would be in feet cube or cubic feet. Okay? All right, well, hopefully that was somewhat helpful. There's a little bit about surface area and volume, and of course you've got those other formulas that you can look back at as well. All right, appreciate you being here for section 1.7 in geometry. We'll see you next time. Mr. Anderson saying so long.